So in this example, we're going to go through how to do a chi-square using JASP, and that includes writing up the results fully in APA style. So for our example, we're at a busy street corner in a large city. A psychologist counted the number of people waiting for the light to change. A graduate student dressed as a homeless man crossed the street against the light, and the psychologist counted the number of people who followed him. When the next group of people collected to wait for the light to change, another graduate student dressed as a well-to-do businessman crossed the street against the light, and the psychology counted the number of people who followed him. So see the data below. So we've got the homeless person, so the graduate student dressed like a homeless person, 3 people followed, 15 did not follow. When it was the graduate student dressed like a businessman, 8 people followed, 7 did not follow. So what statistical test should you use to analyze this data? And then we're going to form an hypothesis, run the test, and write up our results. So the test should be a chi-square because we are using independent data, and that means that the homeless person and whether, or not person, but the person who was homeless, graduate student dressed up as a homeless person, and whether they were followed or not followed was completely independent of the graduate student dressed like a businessman who was followed or not followed, and people were independent. So all of that is independent data. It is also categorical data. So you've got one variable, which would be like type of person, homeless or businessman, and then another variable that had to do with whether they were followed or not followed. And so you've got 2 categorical variables, and then you've got the measurements of how many people fell into, kind of this cross pattern of the 2 different variables. So that is why a chi-square is appropriate. We have 2 categorical variables. We're interested, is there a relationship between these 2 variables? Hypothesis is that there is no relationship. So that's our null, is that there's no relationship between the type of person and if they were followed or not. And our alternative is that there is a relationship between the type of person, and type of person meaning homeless or businessman, and if they were followed or not. So now it's time to run the test in JASP. So to run the test in JASP, now unlike our other ones, this one is a little more complicated, and that's because we can't just copy and paste directly like this. If we did, it would not turn out correctly. So let's go ahead and open JASP. Oh, sorry. Okay, so here's JASP, and we want to go ahead and click New Data. And so this is something a little bit different that we are going to be doing that's not the same as our other ones. So for this one, under column 1, we're going to go ahead and so double click on that one until this comes up, and under name, we're going to put person. And then going to X out. So now we've got, if we click here, when we've got homeless, oh, I wonder if I didn't save that one. So we're going to have homeless and then homeless. And the reason we're having 2 is that we have, oh, apparently that didn't take. Sorry. So person. Okay. There we go. So we've got person, homeless, homeless, so we need 2 of them. And the reason we need 2 is that for followed, and so this is going to be our other one, so followed, or followed, whatever. Okay. We're going to have if someone followed them, so yes, someone did follow them, or no, how many did not follow. And then this one is going to be the count of how many. And I know it's like, what? Right now it might look a little bit crazy, but so we've got homeless, and so this is the type of person, and I guess we could put person type right there just to kind of make it a little clearer. So we've got person, and we've got homeless, and then for followed we've got yes, and that's for the yes they followed, and no for the did not follow. So homeless yes would be 3, homeless no would be 7. Then we've got the businessman, and then yes, and that was 8. And then we've got the businessman, and no, and that was 7. So really important, make sure that your spelling and everything is exactly correct. And the reason is that you want both of these two, the 2 homeless ones, to go together and the 2 businessman ones to go together. And if you do the spelling a little bit different or they're just off, they will count as a 3rd variable, not 2, because technically we have 2 types of person or people, homeless and businessman. And if you spell one of them a little bit differently, we would then have 3. So you really want to make sure you just have these 2. And if you want to double check, you can just mouse over that and you can see for value, we've got businessman and homeless. If one of them was spelled a little differently, you would see 3 there. So let's say, let's spell businessman wrong. Okay, so now if we come up here, you can see you now have 3. So if you click on that and you show 3, you know that, oop, I did something different or I did something wrong. Make sure to fix that. And then you can come back and see, okay, I only have 2 there. For followed, I only have yes and no, so I'm good there. And then count is just numbers. You might want to double check. So homeless, yes followed is 3. Homeless not followed is, oop, see, there we go. That was 15. Businessman yes was 8 and businessman no is 7. Okay, so we are now good to go. And I know that seems a little crazy, and that's why I'm talking through that. Also, for these, person is nominal because it's just a name, right? It's just a categorical variable. Followed also is nominal. It's just a yes or no. There is no right or wrong or anything like that. It's just a name. So both of those are nominal. And then we do have this scale data because it's an actual number. Okay, so for those, we're now going to be able to click the Analyze button. So we now have the data in here. Also, we just double checked it. Make sure now to save. So make sure to go browse, save this file, because you are going to want to make sure that you don't have to recreate this. Or if you go back to it, you want to make sure you know like what you originally did. So make sure you save your file. We're now going to go to Analysis, and let's go ahead and make this the full size again. Okay. So what we're going to do now is go up to frequency. So this is how we're running. So we got the data ready. Now for the actual chi-square, we're going to go to frequency. And this is really important. Make sure you're using classical contingency tables. All right. There is another contingency tables underneath the Bayesian. We are not using that one. We are using classical contingency tables. So make sure you are using this very first one under classical. So classical contingency tables. You're then going to go ahead and put person under rows, whether they followed or not under columns, and then that count wonderfully goes under the count. So you can tell that this all worked by looking in the table, and what they have in that table should match. Granted, it's now businessman. No was 7, yes was 8, and businessman or homeless followed. No was 15 and 3. Okay, so you're just double checking, and that lets you know for sure everything looks right. We do have our p-value, so that's good, but we need a little bit more. So we're going to click under statistics, and we want that Kramer's V. So we want that Kramer's V right there, which we're going to use that. And then under cells, go ahead and mark or check row and column, because we want these extra percentages. The extra percentages are what will allow us to actually interpret the information on the table. So just having those numbers in the table does not allow you to accurately interpret the information in the table. You really have to have those row and column percentages. So now that we have all of this information, this would be what we then, remember, you go to your snipping tool if you're on a PC or on whatever screen capture program you use, and you would want all of this information right there. So just make sure that you have all of that saved and copied into your Word document. So now that we have that, let's go ahead. So we've ran the test, we've got our information. Let's review our results. So we're going to start with our chi-square test results and our p-value right there. So our p-value is that 0.026, and that 0.026 means that we are going to reject the null. So those results are significant. Our p-value is less than or equal to 0.05. We have significant results, and we will reject the null. So very important, with this p-value, we are rejecting the null. The results are significant. So yay, that's the first good thing. Then how to interpret Cramer's V. So Cramer's V is a measure of the strength of the association between those two nominal variables. So that's the strength of the association between the type of person and whether they were followed or not. So how strong is that association? And this table lets you know how to interpret that value. So our value was a 0.387, and we can say 0.387 falls right there into that medium association or moderate strength of association. So medium/moderate, and you can kind of mix and match the words there, whatever one makes the most sense as you're trying to explain it. So it's a medium/moderate association based on our Cramer's V. Then in terms of the table, and I don't actually have information down here on interpreting the table, but the way to interpret this table is for the businessman, if we go across, and so this is count within the row, so we're going to cross because that's the row variable, 53.33% of people were more likely, right, or were likely to follow the person when they were dressed like a businessman. However, if the person looked homeless, only 16.66% of people were likely to follow them into traffic. And so what this is showing is that how you were dressed, right? So if you were dressed like a businessman, 53%, so a little over half of the people were likely to just follow that businessman right out into traffic, even if it wasn't the right thing to do necessarily. But when the person was dressed like a homeless person, only 16.6, so only about 17% of people were likely to do the same. And so that is showing that there is a definite difference. You can also look at it in terms of, for the businessman, 46% didn't, where for the homeless person, 83% didn't. So you could also use that percentage. I mean, that's even probably a stronger percentage there. So it doesn't really matter which way you look at that, just as far as you make sure that you're making that comparison to indicate, like, that's how you explain, like, what did this data mean? What does the results mean? And that just confirms that p-value, which is that there is a relationship. And the fact that there is a relationship, it means something's happening. There is some kind of relationship between, whether you're dressed as a businessman or a homeless person and whether or not someone follows you. We know that it is a medium strength association, thanks to the Cramer's V. And then we can tell from the percentages that people are more likely to follow someone if they're well-dressed than if they look like a homeless person. So that's that big picture overall, what it means. Now, how do we write that up in APA format? So a chi-square test was conducted to determine if there was a relationship between the type of person, homeless man or businessman, and if they were followed or not. And I don't know why I have followed or not twice. That looked a little silly. So let's go ahead. There we go. Whether they were followed or not. Our null is that there is no relationship between the type of person if they were followed or not. The alternative is that there is a relationship. It was determined that there is a significant relationship. And remember, that's the important part. There is a significant relationship between the type of person and whether they were followed or not. We've got the chi-squared, so we've got the x italicized, the squaring is an exponent. The 1 is the degrees of freedom. So there's that 1 with the degrees of freedom. But with a chi-square test, they always want to know what n is. So italicize n and put that in. That's that total sample size. So that's that n is 33. Also, that's a good time to double check, does your n on the table match? Because if you're n, so that's that total value, which is 33 on this table. If it doesn't match the n on the chi-square test, there's an issue there. So we've got that one. We have the chi-square value. We then have that italicized p, and then we've got the p-value, making sure, once again, no leading zeros. The null hypothesis was rejected. super important that you say that. And that appears that whether the graduate student was dressed as a homeless person or businessman did impact whether people followed them. When the graduate student was dressed as a businessman, people followed them 33% of the time, right? 33% the time. When the graduate student was dressed as a homeless person, people followed them 16.67% of the time. Kramer's V was, no leading zeros, was 0.387, indicating a medium association between how this graduate student dressed and if people followed them or not. So this is that full written result that you would need. In addition to, you need the output of those statistical results. And then just to kind of help you, I did include, this is that pretend example of what if those results were not significant. Now, if the results were not significant, I'm going to go ahead and fix that. Oh my gosh, sorry. That's weird. Okay, if the results were not, and I'm even going to save it, this information would stay the same. So this is the same as right here. But what changes is right here. It was determined that there is no relationship, and that's because we changed it to a not significant. So remember, this p-value is now greater than 0.05. So that means there is now no relationship between the type of person and whether they were followed or not. We fail to reject, because remember, if the results are not significant, we fail to reject the null hypothesis. It appears that whether the graduate student was dressed as a homeless person or a businessman did not impact whether people followed them. When the graduate student was dressed as a businessman, people followed them 26.35% of the time. When the graduate student was dressed as a homeless person, people followed them 25.67% of the time. Kramer's V was 0.08. Oh, no leading zeros. Sorry. Indicating a very weak to no association between how the graduate student dressed and if people followed them or not. So this is where, once again, this is an example. We're pretending. So I just made up a p-value, made up some percentages just to kind of show what would you do if that chi-square test was not significant. So how would you write it up if the results are not significant versus if the results are significant? So hopefully that helps you better understand how to do this. If you have any questions, just let me know.